So lesson 3, surface area. So we look at three-dimensional shapes, in particular what's the parts and pieces we need to create to build one of these shapes or paint one of these shapes. That's kind of the way you want to think of a surface area, something that's actually visible. We'll be using the backside of our formula sheet today, so make sure you have that handy. There's a bunch of formulas on there again that we're going to be going through just to refresh in our minds how these things work. The one thing I do want to point out from the very beginning here is when you're dealing with triangular shapes, cones, pyramids, triangular prisms, and lots of times you have triangular shapes that might need Pythagoras because there are actually two different kinds of height we measure in a triangle. We have the vertical height, which in this first case here would be the up and down part. That's our vertical height. And then we have our slant height, which is the diagonal height. So you're thinking about a cone. Okay? If I had a cone, the vertical height would be up from the middle. That would be our H. And the part on the outside, the part you would actually be holding, would be our slanted height. They're related through Pythagoras, so it makes it easier to use, but just be careful about that when you come across some of those kinds of shapes. Like the very first one here, a cone. A cone, surface area, is made up of two parts. It's made up of the circular part at the top and the lateral surface, so the part around the outside. If you think about an ice cream cone, you'd put the ice cream in the circle part, but you'd be holding the lateral part. So if I need this whole shape and I want to paint it, I need to have both parts of it. Before I get started here, I kind of want to think about the formulas, because there are two of them, and the parts and pieces I'm going to need. I need an R, obviously, for radius. It looks like I have that in my diagram. Up here at the top, there's my 40. And I need an S, my slant height, which I just said a second ago was this diagonal part. I don't have it, but we know we can find it using Pythagoras. If we deconstruct our cone here and make it into a triangle, we know that's 40, that's 90, and this is my hypotenuse, my C side. So I can do 40 squared plus 90 squared equals S squared. I'll have 9,700 for S squared. I square root that, and I end up with 98.5 for my S. Then I have the parts and pieces I can use. So I got pi times 40 squared plus pi times 40 times 98.5. You can do this in two separate parts if you want to, and then add them together afterwards, or put it all in your calculator at one time. I'm going to show you the parts just to make sure we're all on the right track with using our calculators. And the second part here is 12,377.9. And altogether, you should get a total of 17,404.4 meters squared. That's how much outside surface is visible in that cone. If we look at the second one here, this spheres are a little bit easier. We're going to only have one part to their formula, 4 pi r squared. The only trick there is to make sure you're using radius, not diameter, which in our diagram we have, the radius that is. So 4 times pi times 5.1 squared. That can all go in at one time on our calculator, and we'll end up with 326. Oops, 326. 0.85, that's meters squared. And that takes us through the first two shapes in three-dimensional surface area.